This is Quentin Lowe, CSC 110, winter 2019 for Mr. Wellman. This is extra credit 8. And so I start by importing math, and this is the is prime equation that you gave us, the faster one. So twin primes is the first one I made, and so it returns n twin primes that are bigger than start. So if zero is put in here and this is 1, then it'll print the first twin prime. But this could be any number. So that way for the later problems, like over like the 51st prime, then we can input what the 50th prime is and it'll start from there. So first I set up the counter in the empty list, and I is made equal to start. So that way, that's the number that it starts from, that it's first tested. So I is increased by 1 each time. And so I is tested to see if it's a prime or not. And if it's a prime and also that plus 2 is a prime, then we know it's a twin prime. And so then the twin prime as a pair in parentheses is appended to the list, the empty list I made at the beginning, and counters added to 1. So that way, since n is the number of primes you want, once that's reached, n's reached that number, it'll stop looping. And then we return the list of the twin primes and also the last prime, the last twin prime. The first number of the last twin prime is also returned. Because that's good for like the 51st prime. We can get the actual value for it here instead of making a new function for it. So for print first 100 twin primes, this is the number of primes that are printed in one row. So if it were 5, it would be 1, 2, 3, 4, 5 like it is here. So for these, we set the variables to 0 first, and then since n is the number of primes that have been printed, as long as that's under 100, which is how many we want to be printed overall, or at the end, it's loops until that's reached. So since twin primes returns 2 variables, we have to have 2 variables here. So we have it return the first row, and starting with start, and start starts at 0. And then start is added again each time. And since this is the last prime, if we add that to start, when this loops, it'll start at the last prime that was given before. That way it doesn't just print the first, whatever this is, number of primes over and over again. And it's printed here. So yeah, that prints the first 100 primes like this. For problem number 2, we have to find the sum of the first 100 primes. So n here is the number of the nth prime is what we start with. So here we use, since twin prime returns 2 things, we have to use we have to have 2 variables to name it to. So this is the last prime that was in this list, and this is the list of primes. Then we use the last prime and the number of primes that's put in at the beginning that we want to get. So this gets us the nth prime, and that way we can start with after that. So for this, we have a equal to first prime and second prime because it's equal to 2 things. And then we can add up, we can add the sum of the primes together. So we add the first prime and the second prime because they're both part of the twin prime. And then, this is also running through the list of the primes after the nth prime, whatever that is. So once those are all added up, the sum is returned. And so for problem 3, we just use this equation, or this function. So from greater than the 0th prime, going up to 50 primes, and then we divide that by the, starting at the 50th prime, the 50 primes after that. And then we get this fraction, or decimal. And it makes sense that it's like 0.2 because this would be much bigger than this, since the 50 primes after the 50th prime are significantly bigger than the first 50 primes. So for problem number 4, so it's the gap between each of the twin primes. So it would check the n primes, the first n primes. So that we set up x is equal to 0 in the empty list, and then we find the last prime in the list of primes from 0 to n, which is the primes that we're checking the gap between. And then we run through the list, and so pretty much I have x set equal to the last prime that was in the list. So I use 0 first, and 3 is the first number that's gotten, and I remove it. Because with the way I did it, the first number is always going to be 3, and it doesn't matter because x is pretty much set to the last prime in this list, and the first time it's not a prime, it's just 0. So we remove 3 at the beginning from the L list. So it subtracts the first prime from the second prime of the last twin prime that was run through this list. And so that way we get, when we add it to the list, we only get the difference between the second prime from the last time it's run through the list and the first prime it ran through the list this time. And then we return the list of those. And then, so to find the biggest one in the first 100 primes, I use the max command, or max function, on this, on the first 100. That way it'll go through the list and find the biggest number, and it'll print that out. And so I got 166 for that.